episode of Mr. Avila Physics. Today we're going to be discussing speed and velocity. Let's start with speed. The term speed refers to how far an object travels in a given time without thinking about the direction of such an object. So for instance, if an object were to travel 240 kilometers in 3 hours, then we would say that its average speed was 80 kilometers per hour. That would mean the distance traveled, which would be 240 kilometers, in the given time intervals, 3 hours. So we could define average speed as the total distance traveled divided by the time it takes to travel such distance. So if I were to express this in formula form, I would get average speed equals distance traveled divided by total time that it took to travel such distance. Let's look at an example, shall we? A person walks 10 meters to the right in 10 seconds, takes a 4-second rest, turns around and walks 6 meters to the left in 6 seconds. What is the average speed of that person? Pause the video here, take a couple of minutes and see if we can answer this video. All right, welcome back. Now, this problem is asking us to find the average speed, and we just saw that average speed would be equal to total distance traveled. That would be 10 meters plus 6 meters divided by total time. And the total time would be 10 seconds plus 4-second rest plus 6 seconds. This would equal 16 meters over 20 seconds, which gives me an answer of 0.8 meters per second. So our answer would be B, 0.8 meters per second. All right, let's move on. Now, velocity, on the other hand, refers to how fast does the displacement of an object change. In other words, it is the rate of change of displacement. In a previous video, we talked about displacement. Talked about how displacement was a change in position and that it takes direction into account as well. So, if I were to say that a car travels 240 kilometers north in 3 hours, then I would say that its average velocity would be 80 kilometers per hour north. Here we're taking into account the change in position, the displacement, along with its direction and a given time interval. Now, this would make that average velocity would be defined as total displacement divided by the time it takes to travel such a displacement. And in formula form, this would be equal to displacement over time, or change in position over time, or final position minus initial position over time. Let's look at an example. So, the same person walks 10 meters to the right in 10 seconds, takes a 4-second rest, turns around, and walks 6 meters to the left in 6 seconds. What is the magnitude of the average velocity of that person? Pause the video here, take a couple of minutes, see if we can solve this example. All right, welcome back. So let's look at this problem. To find average velocity, we need to know two things. We need to know the change in position and the time it took to change that position. So this person walked 10 meters to the right and then turned around and walked 6 meters to the left. So in order to find out the change in position, we first need to assign an initial position. Let's say this is my position x equals 0, which would make this position x equals 4. From here, I can say that my change in position would be this amount right here. This would be my change in position. So let's calculate our average velocity. Average velocity would be equal to change in position, final minus initial, divided by total time. 10 plus 4-second rest plus 6 seconds. This would mean that my average velocity would be 4 divided by 20, which would be equal to 0.2 meters per second to the right. But since the problem only asks for magnitude, we only give its magnitude, which would be c. All right, let's keep going. Now, sometimes speed and velocity are referred to as the same thing, especially if the motion is in a single direction in a straight line, then the terms speed and velocity can be used interchangeably. But there are a few differences between the two. Speed is a scalar quantity which only takes into consideration magnitude, while velocity is a vector quantity that takes into consideration magnitude and direction. All right, let's look at another example. So this example is asking us how far can a cyclist travel in 2.5 hours along a straight road if her average velocity is 18 kilometers per hour. Pause the video here, take a couple of minutes, and see if we can come up with an answer. All right, so here we know that the average velocity, which is equal to displacement over time, is 18 kilometers per hour. So the displacement, which we do not know, over 2.5 hours should give us 18. So here we can solve for the displacement, which would be equal to 18 multiplied times 2.5, and 18 multiplied times 2.5 gives us an answer of 45. So that means that the displacement was 45 kilometers. All right, let's look at our next example. A car travels at a constant 50 kilometers per hour for 100 kilometers, speeds up to 100 kilometers per hour, and drives another 100 kilometers. What is the car's average speed for the 200-kilometer trip? Pause the video here, take a couple of minutes to solve this example, and then come back. All right, welcome back. So here, the example is asking us to find average speed. Average speed is equal to total distance divided by total time. Now, we know the total distance. We know that the total distance is 200 kilometers, but we do not know the total time. So let's look here at the first 100 kilometers. The first 100 kilometers, the car was traveling at 50 kilometers per hour, right? So 50 kilometers per hour will be equal to distance over time. So time would be equal to 2 hours. So it makes sense. If a car is traveling at 50 kilometers per hour, then in order to travel at 100 kilometers, it should take 2 hours. Now let's look at the second 100 kilometers. In this second part, the car was going at 100 kilometers per hour for 100 kilometers divided by time. So the time it took to drive the second 100 kilometers would be 1 hour. So that would make the total time equal to 3 hours. So then here I can say that the total distance was 200 kilometers and the total time was 3 hours, which would make the average speed equal to 66.67 kilometers per hour. So keep in mind that since he is driving at different speeds, then the time for each half of the way is different. So we need to find the time for the first 100 kilometers, the time for the second 100 kilometers. That way we can find the total time. All right. Now there is a term that is very important to learn, which is instantaneous velocity. In order to define that, let's look at an example where you are driving 150 kilometers on a straight road without changing directions in 2 hours. This will make your average velocity 75 kilometers per hour. However, it's very hard to maintain a precise 75 kilometers for the entire 2 hours. There are downhills and uphills, there's other cars on the road, there might be stoplights, there might be traffic, so you might be changing your velocity from time to time. But your average might still be 75 kilometers per hour. All right? Now, the term instantaneous velocity is when we take a very, very small time interval and we calculate the average velocity of that very, very, very small time interval. But in other words, instantaneous velocity is this velocity at a specific instant in time. What's your velocity 30 seconds into the trip? Or what's your velocity at 1 hour, 2 minutes, 3.17 seconds? So a very specific instant in time, what's your velocity? That is what we mean by instantaneous velocity. Thank you for watching.